You already know relationships where one variable varies directly or inversely with another variable. Now you will look at relationships where one variable varies directly with two or more other variables but doesn't vary inversely with any other variable. And that is what we call joint variation. Our objectives for today's lesson are: first, to define joint variation. Second, translate into variation statement a relationship involving joint variation between two quantities given by a mathematical equation. Third, solve problems involving joint variation. Alright, so I have here 6 rectangles. I want you to complete the table by supplying the missing length, width, and area of each rectangle. So in our first rectangle, which is rectangle A, the length is 3 units, the width is 1 unit, and the area of the rectangle A is 3 square units. Now in letter B, or rectangle B, what do you think is the length? Alright, so 1, 2, 3, 4, 5, 6. The length of rectangle B is 6 units, while the width is of course 1 unit, with a total area of 6 square units. In rectangle C, the length is 1, 2, 3, 4, 5, 6, 7, 8, 9 units, and the width is of course 1 unit pa rin. Ang area is 9 square units. Now, in rectangle D, we have 1, 2, 3, 4, 5, 6 units. Yung length is 6 units while the width is 2 units. The area of rectangle D is 12 square units. Let's now proceed to rectangle E. Rectangle E has 1, 2, 3, 4, 5, 6 units and 1, 2, 3 units na width, and whose area is equal to 18 square units. Rectangle F has 6 units na length and width 4 units. The area is 24 square units. The question now is, as the length increases and the width remains constant, what happens to the area? Considering rectangles A, B, and C, okay, as you can see, as the length increases, 3, 6, 9, and the width remains constant, what happens to the area? Alright, we will answer that question later. Another question is, as the width increases and the length remain constant, so considering rectangles D, E, and F, alright, as the width increases, 2, 3, 4, and the length remains constant, 6, 6, 6, what happens to the area? 12, 18, 24. Okay, we know that the area of a rectangle is equal to length times width. Alright? When the length is doubled and the width is the same, the area is doubled. When the length naman is tripled and the width is the same, definitely the area is tripled. Similarly, when the width is doubled and the length is the same, the area is doubled as well. Okay, clearly, the area of a rectangle is proportional to the product of its length and width. So when a variable y is proportional to the product of two or more other variables, then y varies jointly with those quantities. Okay, class, in this example, the area of the rectangle varies with the length, no, when the width is considered constant. Likewise, the area varies with the width when the length is considered constant. Okay? Alright, what is a joint variation? It is a relationship where one quantity increases or decreases proportionally as the product of two other quantities increases or decreases. The general equation of joint variation is y equals kxz. In mathematical statement, it is read as y varies jointly with x and z. Okay, let us recall the different types of variations that we had last time. First, we had direct variation. Y varies directly with x, or y is directly proportional to x, whose equation is y equals kx. Next, direct square variation. Y varies directly as the power of x. The equation is y equals kx raised to n. And we also had inverse variation. Y varies inversely to x, and that is equal to y equals k over x. And we have our lesson today, which is about joint variation. Y varies jointly as x and z, whose general equation is y equals kxz. And now let us translate the following mathematical statements into equations. First, h varies jointly as g and f. Okay, so this is h equals kgf. Next, q varies jointly as w and e. Alright, the equation for this is q equals kwe. Next, we have r varies jointly as t and y. The equation is r equals kty. Next, p varies jointly as o and n. There you go. The equation is p equals kon. And lastly, we have b varies jointly as u and v. Definitely, the equation for this is b equals kuv. Let us now translate these mathematical statements into equations. Let's start with this one. The area of a parallelogram varies jointly as the base and altitude. Alright, so this is A equals KBA. If the given is capital letter, you have to use capital letter. If the given is a small letter, you should use small letter. Next, the volume of a cylinder varies jointly as its height and the square of the radius. And the equation for this is V equals KHR squared. Next, the heat produced by an electric lamp varies jointly as the resistance and the square of the current. Okay, that is H equals KRI squared. Next, the force applied to an object varies jointly as the mass and the acceleration. Definitely, the equation is F equals kma. Okay, the general equation for joint variation is y equals kxz. Okay, for us to solve for the constant of variation or to solve for k, we have to derive another formula out of this. So we will be dividing both sides of this equation by xz to cancel out x and z. Alright? So what's left is k equals y over xz. So this will be our formula in determining the value of k, or the constant of variation. Alright, let us now solve this problem. If y varies jointly as x and z, and y equals 81 when x is 9 and z is 3, Find y when x is 6 and z is 15. Of course, we will be using the 3 steps that we are using since una pa lang. So those 3 steps are: first, transform the mathematical statement into an equation. Second is find the constant of variation. And then the third one is to solve for the unknown value. Alright, in this statement, y varies jointly as x and z. The mathematical equation is y equals kxz. And in finding the constant or the value of k, we have k equals y over xz. Our y is 81, our x is 9, and z is 3. So substitute nyo lang yan. So we have 81 over 9 times 3. 81 over 9 times 3 is 27. And then 81 divided by 27 is equal to 3. Our k, or the value of the constant of variation, is 3. We can now solve for the unknown value. We can now solve y when x is 6 and z is 15. Using this equation, y equals kxz. Our k is 3, our x is 6, our z is 15. We then substitute, no? Kaya naging ganito. So 3 times 6 times 15 will give us 270. Therefore, y is 270 when x is 6 and z is 15. Next, if P varies jointly as Q and R, and P equals 2 to 5 when Q is 3 and R is 5, find P when Q is 6 and R is 7. Of course, again, we will be using the 3 steps. The mathematical equation for this mathematical statement, P varies jointly as Q and R, is P equals QR, KQR. Again, P equals KQR. And the value of K is given or determined by P over QR. Our P is 225, our Q is 3, and our R is 5. To substitute, we have 225 over 3 times 5, and that is 225 divided by 15. 225 when divided by 15 is 15. Our k is now equal to 15. Let us now find P when Q is 6 and R is 7. Using this equation, we have P equals KQR. Substitute the values of K, Q, and R. K is 15, Q is 6, R is 7. 15 times 6 times 7 will give us 630. Therefore, the value of P is 630 when Q is 6 and R is 7. Next, if A varies jointly with B and C, and A is 60 when B is 4 and C equals 5, find B when A is equal to 126 and C equals 6. Again, using the 3 steps, we can now be able to solve for the unknown value. First, let us translate this statement to equation. A varies jointly with B and C, and that is equal to A equals KBC. The constant of variation is A over BC. Our A is 60, our B is 4, and our C is 5. So 60 over 4 times 5 is 60 over 20. Our K now is equal to 3. Let us now find B when A is 126 and C equals 6. As you can see, the missing value is B, but our formula is, the equation is A. So you can use this formula as well in finding B. You can substitute directly, the given to the formula. But you can also derive a formula in finding B. We will be getting the same answer lang din naman. So let's substitute. A is 126, our K is 3, our B is missing, and C is 6. We all know that 3B times 6 is 18B. So this is definitely the same as 126 equals 18b. Alright, 126 divided by 18. We divided both sides by 18 to get rid of 18 here. And b now is equal to 7. Okay, let us apply those concepts in solving word problems. The area of a triangle varies jointly as the base and the altitude of the triangle. If A equals 65 centimeters squared, when B is 10 centimeters and H is 13 centimeters, find the area of a triangle whose base is 8 centimeters and whose altitude is 11 centimeters. Alright, in answering problems like this, you have to know what is asked and of course what are the givens. And since we are talking about variation, you have to translate the mathematical statement into an equation. So the mathematical statement in here is the area of a triangle varies jointly as the base and the altitude of the triangle. So technically, or in short, we can say that A varies jointly as B and H, and whose equation is A equals KBH. Okay? And the value of K, to solve for K, we have K equals A over BH, or B times H. Our A is 65 square centimeters. Our B is 10 centimeters and our H is 13 centimeters. Simplify further, 65 equals 10 times 13 is 130. 65 over 130 when simplified is 1/2. Solving for the unknown, which is the area of the triangle whose base is 8 centimeters and whose altitude is 11 centimeters, we will be using this equation, A equals KBH. K is 1/2, B is 8, H is 11. So 1/2 of 8 times 11 is 1/2 of 88. 1/2 of 88 is 44. So therefore, the area of a triangle whose base is 8 centimeters and whose altitude is 11 centimeters is 44 centimeters squared. Okay, you have to put a unit of measure here. So this is 44 square centimeters. Next, in science, kinetic energy varies jointly as the mass and the velocity. A mass of 10 grams and a velocity of 5 centimeters per second have a kinetic energy of 100. Find the kinetic energy for a mass of 6 grams and a velocity of 9 centimeters per second. Okay, as I have mentioned earlier, you have to know what is asked and what are the givens. And you need to translate the mathematical statement into an equation. In this case, the mathematical equation is kinetic energy varies jointly as the mass and the velocity. So E varies jointly as m and v. And that is E equals kmv. Our K is E over mv. So a mass of 10 grams, so therefore our m is 10. A velocity of 5 centimeters per second, that is our v. And our E is 100. Let us substitute those to the formula. 100 over 10 times 5 is 100 over 50, which is equal to 2. Solving for the kinetic energy for a mass of 6 grams and a velocity of 9 centimeters per second, so that is E equals kmv. Our K is 2, our m is 6, okay, and our v is 9 centimeters per second. Therefore, 2 times 6 times 9 is equal to 108. I hope you learned something. Thank you. Goodbye.